Hello, we're in the last lesson of Unit 2, so it's Lesson 7. This is dealing with some key features, some key functions. What we need here is the terminology, the correct terminology is what we're focusing on, based upon graphs and information or questions that they're asking. So we're looking at exercise 1 at a graph that they have drawn for you. So don't worry about what the equation is, but you have to be able to interpret the graph based upon its representation. So A wants you to find the y-intercept. So of course the y-intercept is where it goes through the y-axis. So the y-intercept of the function is 0, 2. That's the y-intercept. Okay, x is always 0. Now, state the x-intercepts of the function. So the x-intercepts are where it goes through the x-axis, and that's at 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So we have 4, 0, and negative 6, 0. So there are two x-intercepts. And what is the alternative name that we give the x-intercepts? They can call them the zeros. What are the x-intercepts? What are the zeros? What are the solutions? Those are all synonymous when you're finding the x-intercepts. Now, we're looking at the interval from negative 1 to 2, the x values. So we're looking from negative 1 to 2 right here. Is that increasing or decreasing? So and that's always from left to right. So as I look from left to right, I start here. Where am I going? I am going up. So therefore, that is increasing. And how can you tell? Because as I look at the graph from left to right, the graph is going up. That's fine. It's kind of a basic question. Give the interval over which f of x is greater than 0. What is a quick way of seeing this visually? So my f of x has to be greater than 0. So that means that f of x, remember, is your y. So all my y values. So it's everything above the x-axis. So everything up here, that is going to be where f of x is greater than 0. Now the key thing is, see how it says greater than 0? Can't be equal to it. So it's got to be greater than 0. So give me the interval. So it starts at the zeros. Not always, but in this case it does. So interval, negative 6, so 4, and it has parentheses because it is not included because of this right here, because it says greater than, not greater than or equal to. State all the x-coordinates of the relative max and relative mins and label each. So relative max and mins are your turning points. So my turning point, this is a starting point right here. Starting point, this is the ending point. Okay, so my turning points are 1, 2, 3, 4. Okay, where it goes from increasing to decreasing and decreasing to increasing. Now you can still see the graph on your paper, you just can't see it on your screen. So state all the x-coordinates. So the x-coordinates were x equals negative 4, x equals negative 1, x equals 2, and x equals 5. So they're all relatives. So they're relative, relative, relative. And negative 4 at x equals negative 4, the output is here. So that is a relative max because it goes up to it and then turns increasing, hits the point, and now is decreasing. At negative 1, that's a relative min. At 2, it is a relative max. And then at the 5, it is a relative min. Okay? Now the absolute max and min of the function. So the absolute max and min are on the graph. What is the highest point? Oops. What is the highest point? I don't know what I'm doing here. I just wanted to erase it. Okay, so the highest point, and that includes any portion of the graph. Could be anything at all. So the highest point is here. The lowest point is there. Okay, so that's your max and min of the entire graph. So my absolute max So the max is has a value of -4 when x is -8. The min, oh, did I mix that up? No, that's supposed to be min. Sorry. I don't have time to redo the whole video. Sorry about that. That's the min of -4 when x is -8. The max is 8 when x is 2. Okay? So then you want to state the domain and range of the function using interval notation. So remember, you box it in here. Well, it's kind of already boxed in. We just need this one here and this one here. Okay, because everything else is right on the end of the graph that they showed a snapshot of. So you just count. Remember, the domain are your x values, and it's all inclusive. So the domain of your x values goes from -8 to 6, and the range goes from -4 to 8. Remember, you go in order, like you would put it on a number line. If a second function, right, so now if they want to find a rule or some terms for the second function, is defined by the formula g of x equals 1/2 f of x plus 2. What is the y-intercept of g of x? So the y-intercept is always going to be where x equals 0. So g of 0 is going to be 1/2 f of 0 plus 2. You rewrite the equation, just put 0 in for x. So then you find f of 2. So you look at your graph, f of 2 has an output of 8. So then you have 1/2 of 8, which equals 4. So the y-intercept is 0, 4. That would be the y-intercept of the second function. Okay. When we get on to exercise 2, so consider the function g of x, 2 absolute value x minus 1 minus 8, defined over the domain -4, less or equal to x less than 7. So sketch the graph of the function to the right. So when you're sketching this graph, all you do is just put in your calculator. So remember what to put it in the calculator. The absolute value button is to the right of the 9. Okay, so when you put that in, but I had to get out of there first, didn't I? So I had to put a 2 outside, and then the x minus 1. And then get out of there, and then -8. Some people on the quiz had the absolute value. They must not have used the such that because they had a wrong output value for an input. So just a little side note. Now you want to define it over the domain -4 to 7. So Control T, and you're only looking at a snapshot of this graph from -4. So there's 2, and it goes to 7. So you're just going to plot those points. So merely take them from your calculator and put them right on the graph. So at 1, 2, 3, -4, I was at 1, 2, 3, 4. I was at 2, and then I'm pretty sure that this is where they are. Down, I think it goes down to over 1, and then here, and there, and that's the bottom, and then back up, up. How far do I have to go? Yeah, you put them all because you have to go for the entire restricted domain. So it looks something like that. So there's sketch the graph. State the domain interval over which the function is decreasing. So the function, no, remember the domain interval. The domain are your x values. So my domain interval for which the function is decreasing is -4 to 1. And it could be either parentheses or brackets. Either one is acceptable. Okay, so -4 to 1. State the zeros of this function. Of the zeros of the function, and 0 and 0. 1, 2, 3, 1, 2, 3, 4, 5. Okay, so the zeros are -3, 0, and 5, 0. Okay, so those are the zeros. State the interval over which g of x is less than or equal to 0. So we looked at the one previously where it was greater than. Less than is going to be below. Okay, so all this. So the key thing is it's going to be an equal sign this time, less than or equal to. So it goes from -3, less than or equal to x, less than or equal to 5, okay, or -3, and it has to be brackets, negative 3 to 5 like that in brackets. Has to be. Evaluate g of 0 by using the algebraic definition of the function. What point does this correspond to in the graph? So if I'm doing g of 0, so I plug in 2, 0, minus 1. Oh, that's supposed to be absolute value. Minus 8. So that's the algebraic definition of the graph. So you have to evaluate it, g of 0. Okay? So then you plug it in. This becomes 1. Yeah, somebody with these absolute values, got to remember, it makes everything positive. So 2 minus 8 is negative 6. What was it? What point does it correspond to? It is the y-intercept. Are there any relative max or mins? Remember, that's a turning point. So there is only one, and that's the bottom one right here. That right there. Okay, that's your relative min. So we have a relative min, and that coordinate is 1, negative 8. So there's a lot of information there that you have to be able to interpret from a graph or a function that they may give you. Now, they could also give it to you as a table. So we have a continuous function in the domain of negative 6 to 13. So they're just giving you select points. The function has exactly 2 zeros and 2 turning points. So 1 at 3, 4, 3, negative 4, there's a turning point, and 1 at 9, 3, that's a turning point. The zeros, there's 2 zeros, so the zeros are negative 1, 0, and 8, 0. That means that's where it crosses the x-axis. 0, negative 2, this one here, that is my y-intercept, because the x value is always 0 on the y-intercept. So we want to state the interval for which f of x is less than 0. So we can look at our table, and you see your zeros. So my y has to be less than 0. Okay, so here are my 2 zeros, here and here. Okay, you see how these guys here are all negative? So therefore, the interval for which it's less than 0 is negative 1 to 8. And they're parentheses because of the less than. So be careful of that. State the interval over which f of x is increasing. So we want to say where it's increasing. Okay, so how do we know if it's increasing? So what happens is, as we look at this, we go from 5 to 0. What's happening there? So we're at negative 6, 5, negative 1, 0. So that's decreasing. Still decreasing here to 2, negative 2. Still decreasing at negative 4. What finally happens? Look at this. It's starting to increase again. So it goes negative 1. 0 is also a larger number. 3 is a larger number. Okay? So it picks up right here and goes to there. So it starts at 3 and it goes to 9. And again, with increasing, decreasing, it can be either parentheses or brackets. So that's where it is increasing from 3 to 9. Okay? So if you have any questions, save them for me for Monday. I'm not here Friday. If you already watched it over the weekend, if we watch it over the weekend, that's all right. I'll still see you Monday. Okay. I will see you in class.